Hey everybody, this is Larry, this is me over Q3 of the bi-weekly contest 173, find maximum value in a constraint sequence. Hit the like button, subscribe button, join me in Discord, let me know what you think about this one. First of all, I want to reiterate, because sometimes people complain for whatever reason, that this is not just an explanation video, it's about my experience and my, trying to go over, look, listen, you can look up the solution. You don't really need a video for that, right? But for me, it's just about how I arrive at the answer, how I arrive at the solution, and hopefully that gives you ideas to kind of how to attack it from your perspective, right? By seeing it from my perspective. It's not. I mean, sometimes it looks magical. Sometimes it looks like, oh wow, Larry just knows the answer. But it's from like, and I would tell you straight up that a lot of those cases is because it's just from years of practice, whatever, right? But for problems like this one, where like I do go for a lot of different thoughts and playing around with different ideas, and I'm gonna go with some of those and how I kind of eventually got this one right. And hopefully kind of give you ideas. But for this one, honestly, I end up taking 15 minutes, and I did not know how to do this one for a long time. What I was thinking of that I mean, I had the idea correctly. I had an n squared solution very quickly. The idea behind an n squared solution is just that you could kind of simulate the max, right? Because basically, you can for each space index. For each index, you can basically recalculate the max based on its neighbor, and if its neighbor changed, then you recalculate it again, and then basically you kind of keep looping until nothing nothing else change, and this can happen n time. There's an n array, so this is n squared. So I'm a little bit hand wavy, but there's a very straightforward n squared solution, right? But from that idea, then the key part about that idea is just that, one is that the maximum value of the indexes are monotonically increasing, or sorry, decreasing, right? You start with infinity, and then just kind of keeps getting smaller and smaller. And then, of course, maybe I skipped this because it's part of the inputs, but I should make this explicit. Is that the restrictions that they give you, that's part of the initial max thing, that your initial conditions. So I was thinking about that, and I was thinking about playing around with, like, and I'm not gonna lie, like some sort of solver type problem, maybe some sort of like constraint solver, right? And I was also thinking about, though it doesn't really make sense, but I was thinking about some sort of using this diff for like prefix sum, and then you get these lines, and then it's basically you have n lines, or well, maybe n times 2 lines, depending how you want to say it, because you can think about each restriction as, for example, there's a 1, and then to the left it's gonna be 3, 5, 7, so then you have like 1 point, and then you have like these lines going up, to it, and then the next restriction there's points, and then you try to find like the intersection and then min of all that and stuff. So definitely was thinking about a lot of these ideas and have these visualization. And honestly, that was it, right? The line intersection was that, well, yeah, it came to me that this became a sort of a shortest path problem, which we can solve using a heap and Dijkstra, and that's basically what I end up doing. I don't know if this is like the canonical way of doing it. I don't know if there's an easier way. I don't know, but look. But that's basically what I end up doing. I start with restriction. I just kind of append it as the 0 index at 0, because then I don't have the special case. I just put it in the restriction. Then we just have a heap. We set all the max everything to infinity. Nothing is done, right? I don't know if this part is necessary per se, but either way. Yeah, and then for each restriction, remember that includes to 0, 0. We set the max to that value, and then we put in the heap. The idea behind the heap is that we just, for each lowest thing, we go to its neighbor, and then we add we do add the max that we can do with the diff, right? And as a result, then you kind of based on it, and because the reason why the visualization for me works is because maybe I should just draw it out. All right, let me draw it out. Hang on. Maybe I was trying to be lazy because, well, I wasn't super trying to be lazy, but I didn't think it actually is relevant. But then the more that I think about it now as I'm talking about it, it makes sense to kind of draw it out because then the relationship is more obvious. But yeah, but the idea here is that, okay, well, you know, you have a line graph, and you know, let's just say you have some indexes, and this one has to be 0, right? So then now this is your cap, right? Let's say this is your cap, and then you have other let's just call it constraints. I forget if they call it restrictions or whatever, but constraints that are like here, you know, they're in the input, right? And you have additional kind of what I would say a line that for each of these constraints. Next to it is the maximum that it can be going up or down, right? So it may look something like do 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 do. I don't know why it sounds right? And then maybe same for this one, right? You know, and then the idea for me, right? And my first idea, like I was saying, is try to, you know, figure out all these intersection points and stuff. But I don't want to draw everything. That's fine. Okay, I just draw lazy lines then, right? Something like that, right? But but it came to me that, well, this intersection, but that means that everything, well, one is that it's too slow because we also have to like fill out like this stuff anyway, right? So it's not like, you know, but that also reminds me of a shortest path problem because for every index, for example, maybe say here, well, this one got there first before this one, right? And that's kind of the way to do it, and that I thought about it. And you know, you can imagine other lines are the same, and that's the basis for kind of this shortest path idea. Yeah, but otherwise, honestly, everything else is just dexterous after that. After you set it up with the initial restrictions and 0, 0. Yeah, this is just Dijkstra. This is Dijkstra setup. We go right, you know. Yeah, this is the cost to go right. Well, that's the new max if we gone right. We check it to see if it's under the current, you know, whatever we put in, and we also do the same thing for the left. We have to be careful about the indexing. I spent some time debugging that one. But yeah, you know, there's a heap. It's Dijkstra. It's gonna be n log n, right? And that's it. That's all I have with this one. Let me know what you think. They're only for this problem. They're only n nodes. Well, I guess they're usually n nodes, but only n edges because or O of n edges because you can only go left and right? So everything's n log n. And that's it. That's all I have with this one. Let me know what you think. Make it slightly smaller. Does it fit? Close enough, maybe. You know that infinity is infinity, right? Yeah. Thanks for watching, and you can watch me solve it live during the contest. Now, okay. I guess that was the only edge case. Those ones I always worry about off by ones for me. Is non-negative. The delta is diff sub I. Okay. What is restrictions? Oh, just cannot. Oh, this is the max value. So that means that a 3 has to be almost 1. That's interesting. Hmm. 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 I mean, I definitely have ways to solve it, but I'm trying to think about of n. This one. Hmm. What does this one mean? I know that the 1 and the 3 is why this is 4. Actually, well, I guess this 2 is kind of there to kind of trick you, actually, it feels like. Because it could be like 10, 10, it doesn't really matter, right? It'll be just 10 and then 4 anyway. Is it enough to go back and forth? Maybe it is. Let's try it. I'm quite confident about this one, but first number is 0. Okay, so the max. Let's go M. Less typing. No, I don't think that works. There's an idea, but I forget what it is. I mean, because I've done this some similar things like this before, but I feel like maybe I'm wrong. Oh, what the? This is. I hate that they sometimes hide like very critical constraints in the constraints. I should have looked at it more carefully. I did look at this one, but I didn't look at all the other ones. What's max value again? Is it just this one? That's 10. 10 means something, right? Does it mean? Well, it definitely means something. I mean, it does simplify things a lot. I'm trying to think. What I'm thinking now is whether I can DP as a result of that. No, I mean, that's basically what I was doing anyway. You have to back propagate the actual max. But does the 10 limit the things that we can do? I mean, I think the visual. I don't know that I understand this one. Okay, so there are all these constraints. You don't really have time to check against all of them. For each index. I guess it's like a buffer search. Would a buffer search make sense? Maybe it does, actually. So I was trying to keep on figuring out how to like back propagate. But maybe buffer search makes sense. So then, okay. Huh. Okay, maybe that does make sense. And this is yeah, okay, maybe. So I said buffer search, but it's rated, right? So it's heap. basically this is the new max. Yeah, okay, fine. And just go left or go right, right? So there's an index, so to go right is going to be diff index. I guess actually this is a bit more mature. This is just Q3. I'm not even doing Q4 yet. Okay, index plus 1. Okay. If this is okay. 'I guess this could have been loop. Maybe. No, it could have been, but I just have to write it a little bit differently. 11, 12. That's not right. Right? 0, 2, 1. I think I'm just off by 1 because this one should not look at the 1 to go to here. So 0 looks at 0. Don't mess up. It's going to the right, going to the left. So if this index is 0, 1, 2, 3. Now it should be, so if the index is 0, 1, 2, 3, it should look at 0, 1, 2 for this one, right? Did I? Oh, I did have an off by, well, not an off by 1, I just have a typo. Okay. Wouldn't be surprised about more, but okay. I mean, that was a harder reduction than I don't know, than I imagined, honestly. I struggled with that one. People, as usual. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.